have other ways of defining tuples. In this case, we could create different limits depending on the method. So maybe there's a kind of a default limit of 5 requests per user, but for GET requests, we want to actually have a lower limit of just 2 per user. This is related to a use case that we hear from customers called load shedding, where you basically have kind of different controls, different kind of fine-grained ways to provide, limits. And here we're leveraging kind of the fact that Envoy's config for rate limit is quite expressive. So we can actually, not just express multiple rules, but there's as before, we have these nesting of rules, and we actually have kind of, we're looking at kind of, 2 different quotas, one on just a single tuple of the remote address and one on more of a nested, more complex rule. So let's see what this looks like kind of from the command line. So first, I'm just going to apply this, like before, as just a patch to our settings. And as we've been seeing, that's what basically triggers Gloo to tell the rate limit server, here are the quotas for these different kind of tuples of descriptors. And then we can connect that to our actual route by adding the rate limit options and creating these actions on our route. Now, in this case, the actions look a bit different. So before, we had 2 actions that both had a generic key on the top. One said per minute, one said per second, but now they look a little bit different because we're incrementing essentially a counter just for the remote address. That's our 5 requests per second limit, and also incrementing a counter for a specific method in addition to that remote address. And in this way, we should be able to kind of see a lower limit for specific method of GET, where we've created that 2 requests per second limit, and we can still enforce the larger limit of 5 per second on the client. So let's see that in action. So I'm going to patch again. And throughout these examples, I'm using this command to apply the patch. Basically, we keep editing the same section of a single resource. So I'm just applying it as a merge patch to highlight the patch itself. But we had the actual kind of complete virtual service, so I can just apply this. So now what we should see, our default HTTP method when we issue these curl requests is GET. So we should see our rate limit on GETs, come through after 2, just as we expect, just as we had configured. But we should see, if we issue other methods, we see that we aren't hitting that limit. I think we had a limit of 10. So yeah, so after I issue enough requests, we do hit the limit on our default fallback limit. So what this shows is, we can really do something similar to what we did before, but we don't need to just use kind of a generic, per minute, per second kind of key to identify, which part of the plan that we're in. We can actually create more complex logic, maybe by load shedding, some traffic for GET requests that are coming in, as in this example.